So I made my change to draw lines, and this is how our teapot looks this time. And so let's just do a little bit of rotation here to bring it forward. And yes, so you can see that this time everything is rendered as lines. And if I make it a little larger, you can see that we're still doing the light computation on this shape. So even lines respond to all the light computations. Okay, so this is definitely a very useful option to debug your programs. Sometimes you need to realize how this geometry is being put together and how is it looking as a wireframe. You can also draw individual points. So these are the lines that I just made in this teapot, and we can also change the thickness of these lines. Right now the thickness of these lines is 1 pixel. It's the smallest one, but we can change the width or basically the thickness of individual lines, and they will be drawn accordingly. We can also do a line strip, which is basically drawing the lines like this, one after another. So basically, when we specify our vertices, we don't specify lines as segments. We basically have a starting point and then move to the next one, to the next one, and to the next one. And so each vertex, each additional vertex specifies the next line to draw. So I don't think this one was rendered by line strip, but it's one of the possibilities. We can also do a line loop, which basically closes the loop to create an outline of something. Triangles just connects 3 vertices. So when we want to draw triangles, what happens that all drawing is supposed to be done with 3 vertices, which will correspond to forming the geometry of a triangle. And of course triangles, so we'll continue drawing these triangles, and right here you see that our entire drawing is made up of individual triangles in this teapot shape example. Triangle winding is an important idea, is that when you draw the triangles, and when we specify our triangles, we realize that they can be specified clockwise and counterclockwise. So if this is the triangle that faces the viewer, then this is an example where the first vertex, right here, this is the first vertex, and there are 2 possibilities here. There could be vertex this way or this way. So if we go this way, and if we complete this triangle, clearly this is the clockwise direction, and this one is the opposite. We start with vertex 1, and then the second vertex we specify here, and the third one here. So obviously here we go and proceed counterclockwise in this direction. Why is this important? Because we say that this is how we specify the front face of our polygon. And when most of the time when we do our rendering, we use counterclockwise rendering in OpenGL as front facing. This is the default. And clockwise is sort of like back facing. And what is possible to do is that we may say that we would like to render only front facing triangles and discard back facing. Why? Because we can save a lot of computation, because we only want to be able to draw the front part which is visible and ignore everything that's over there in the back. This is just a waste of time. We want only the front to be rendered. I can try to make this change right here in our polygon mode. Right now I'm asking the hardware to draw all of the triangles, but I can try to switch only to the front triangles, basically discarding this part, and we can try to see what is the difference if we make this change. And after restarting this program, you see that now I'm actually drawing only front face triangles, and the back face triangles appear to have this green color in the back. This is just the way the colors are assigned in this demo. There are also triangle strips and triangle fans. Basically, this is an example of triangle strip, where we say that we want to draw like an area formed with triangles. So this could be a part of the surface right here on this teapot, and we start with the first vertex of the first triangle, and then we proceed to the second vertex and the third vertex, and as soon as we reach the count is 3, now we have our first triangle. And then to form the next triangle, it only takes one step, and we already have vertices 1 and 2, and 3 only adds to it, and this is our second, and then this is our third, and this is our fourth. So with just one additional vertex, we draw the entire triangle. So obviously something like this will optimize the processing of our vertices to specify the geometry. And likewise with the triangle fan, it's similar to triangle strip, but here we start with one vertex, and then go to the first one and the second one. So this is our first triangle, and as soon as we proceed to the third one, it basically adds to the fan, and then it adds again here. And so if we continue drawing these triangles, the first vertex it will end up in the center of the polygon or surface that we will specify using the triangle fan mode. So these are obviously rendering options that we need to be aware of, and it depends on your project, and depends on what you do with your geometry overall. So culling and depth testing is typically applied in all programs, and currently I am using it, and it really has to be taking place in 3D graphics rendering mode, because if we do not specify that we want to do the depth testing, and let me show you how this is specified. So we do this right here with our glut init display mode, and then we also have to enable it. So this is a depth test being enabled in my code for this rendering, and it just appears that if we have 3D space and we want this object to appear closer to us and the other object to be further away, so therefore this is the appearance. Without depth testing, it may be rendered incorrectly. Basically, without depth testing, it may appear like this, that the object which is further away will strangely appear to be covering the object that's supposed to be closer. So it's just a kind of strange thing. But sometimes things can be optimized, and you don't maybe you don't need depth testing all the time, but most of the time you want this to be enabled to avoid those strange artifacts where you know, front and back are mixed up when things are rendered on the screen. And we already talked about backface culling, so right now that's what's happening, is that we're removing triangles from the back. Essentially we say don't draw triangles that don't face the camera, and remember that the default mode of rendering is the counterclockwise. So when we specify our vertices in this order, this is clearly going counterclockwise, so this will be front-facing triangle. And if we begin to rotate this triangle, right, so if I just rotate my geometry right here, so whatever was front-facing here now turns to be back-facing on the other side. So that is just basically the idea that we don't want to draw any triangles that are not facing the camera. So that's just also obviously a useful idea to optimize rendering and make things run faster. Depth testing, something that we already discussed, and I already showed you these two calls into GLUT, and then OpenGL enabled depth testing, and that's definitely the best mode to keep it on when you are doing 3D rendering. Alright, so Polygon rendering modes. Right now I'm using lines. So the default is fill, and fill is not a wireframe display but just display of surfaces. Okay, so we can also try to change to draw points. So let's try this change in our Polygon mode. So you can see that right now I'm drawing lines, so I'll switch over to individual points. So if I change my Polygon mode to point, and I actually will switch back to front and back to display it, front and back, and we'll try to draw individual points. And you see, after restarting my program, now the teapot is drawn with these little points, which we can try to bring closer together to make it a little bit more you know, recognizable as a teapot. But nevertheless, now it's all drawn with individual dots, and each dot is just one pixel on our screen. But of course we can actually change the size of points just like we can change the size of lines. I'm not going to experiment with this right now, but that's the idea. We can display points instead of entire faces. Alright, so sometimes also we can have undesirable artifacts when we're doing depth testing, and triangles end up very close at the same depth, so that could result in removal of incorrect triangles from being displayed. There are some techniques that we could employ to avoid these artifacts. There's also Scissor Tests that we won't be using this in our code, but it can increase the performance so that the updates are done only to a portion of a specific area. So the idea is that we know exactly what we're doing, and instead of updating the entire viewport here, we'd be just focusing on a certain part of the viewport and access only part of the display to make changes and make updates to an existing drawing. So let's switch back to draw the entire surface. And it should take me only to comment out this polygon mode point or line, because the default is to draw triangles. And as I restarted the program, you can see that now it's rendering the 3D shape. Well, blending is about blending of colors, so sometimes if we are not using depth testing, then color values could override one another, but perhaps we want to make this color combination more transparent. So with depth testing, the new fragments may replace the old ones, but discarding further fragments does not apply with OpenGL blending. So if we enable blending, then the colors will be combined, and we can specify how to blend. I'm not going to tell you a lot of details, and I simply don't have capacity to demonstrate blending here. It could be with kind of like simpler shapes, but so I'm going to skip all the details, but basically these are the effects of blending. So this is without blending, and now this is with blending applied. So you can see that the colors actually mix and provide an effect of sort of like transparency, so that this rectangle here appears to be transparent, so or see-through effect happens as we go. So there's some blending equations, and we have plenty of examples of how to apply blending if that's what you want, if this is your goal. Anti-aliasing is simply to avoid undesirable effects caused by square pixels, which make image look more like computer generated than more natural appearance. And so that is coming from the jagged lines. I will try to undo multi-sampling in our next segment, and we'll see the result of this.